Hey everyone, welcome to today's Explainer. If you're gearing up for competitive exams, you already know the drill. The computer knowledge section can absolutely make or break your score. So today, we are dedicating our time to cracking that code. We're going to decode the core concepts, trace the wild history of computing, and master that massive list of tech abbreviations, so you can walk into your exams with total confidence. Here is our game plan for today. 1. Decoding the word computer. 2. Looking at categories and components. 3. The 5 generations of computing. And 4. Cracking those tricky abbreviations.
All right, let's dive right into part 1. Decoding computer.
So, did you know that the everyday word computer is actually a massive hidden acronym? It's true. It stands for Common Operating Machine, purposely used for technological and educational research. I know, it's a total mouthful, but it's absolutely crucial to memorize. It actually comes from the Latin word computerae, which literally just means to compute. Basically, it's an electronic machine that takes in data, crunches the numbers, and spits out your outcome. Under the hood, a computer really just boils down to a super simple formula, the ALU plus the CU. Think of the arithmetic logical unit, the ALU, as the brain's raw muscle. It does all the heavy math and logic. And then you have the control unit, or CU, acting like a traffic cop. It manages the whole flow, making sure every single operation happens in the exact right order.
Which brings us nicely to part 2, categories and components. Computers are essentially categorized by how they process data. There are 3 fundamental types you need to lock in here. First, you've got digital computers, which process discrete ones and zeros. Second, analog computers. These measure continuous data, like temperature or pressure. And third, hybrid computers, which, as you might guess, combine the best of both worlds.
Now for part 3, the 5 generations.
It's time for a little time travel. We're looking at how we went from massive, room-sized, heat-cranking machines to the incredibly powerful devices sitting right in our pockets today. Try to anchor these eras in your mind. Notice how the gaps between them actually shrink as innovation speeds up. We kick off with the first generation in 1946. The second gen hits about a decade later in 1955. The third gen pushes us to 64. The fourth gen really takes over in 78. And finally, the fifth generation runs from 1991 all the way to the present day.
Let's contrast those first two because the leap is brilliant. The first generation relied on these bulky, incredibly hot vacuum tubes. Think of the famous ENIAC machine. But then the second generation changed the game with transistors. They were smaller, they were cooler, just totally revolutionary. Memory got a huge upgrade too, with magnetic disks paving the way for high-level languages in machines like the IBM 1620.
And that trend of shrinking size and exploding computing power, it just kept going. In the third generation, transistors were packed into integrated circuits, or IC chips. Then, the fourth generation brought us very large-scale integration, or VLSI. By embedding over 1,000 components onto a single chip, we finally birthed the personal computers we know today, like the classic Apple Macintosh.
Which brings us to the world we are living in right now, the fifth generation. From 1991 onward, VLSI evolved into ULSI, Ultra Large-Scale Integration. But what truly defines our current era isn't just those tiny chips. It's the insane new technologies they enable. We are officially in the age of artificial intelligence and machine learning.
All right, moving to part 4, cracking of the abbreviations, the ultimate decoder ring.
Understanding the history is awesome, but to ace these exams, you literally have to speak the language fluently. We've logically chunked the most highly tested acronyms to make them easy to memorize. Let's start with hardware essentials. The brain of the operation is your CPU, the central processing unit. For memory, be really careful not to mix up RAM, your random access memory, with ROM, your read-only memory. Oh, and definitely keep an eye out for SMPS, which stands for Switched Mode Power Supply. I want to hit pause on the rapid-fire lists for just a second because there's a standout here that always blows my mind: virus. We use the word all the time, right? But did you know it's actually an abbreviation? It stands for Vital Information Resource Under Siege. How wild is that? It's not just a buzzword, it is a literal perfect description of what malicious software actually does to your system.
Okay, jumping back in with storage and displays. You're definitely familiar with the compact disc, or CD, and the digital versatile disc, the DVD. When you plug them in, you're probably using a USB, the Universal Serial Bus. Now, for those older, chunky monitors you used to see in the 90s, CRT means cathode ray tube. And for archiving data, look out for DDS, which is digital data storage.
Here is another highly specific, heavily tested abbreviation you absolutely need to pull out and memorize on its own. SAP. This stands for System, Application, and Products. Seriously, when you see this on the exam, don't overthink it, don't second-guess yourself. It's System, Application, and Products.
Now, let's talk about the backbone of the internet. When you type in a web address, you're using a URL, a Uniform Resource Locator. It gets fetched using HTTP, Hypertext Transfer Protocol. And that S you sometimes see at the end, it simply means secure. All of this global communication relies heavily on your IP, or Internet Protocol, and TCP, the Transmission Control Protocol.
To keep that whole machine running smoothly, you need power and graphics. Have a sudden outage? You'll definitely want a UPS, an uninterruptible power supply, which is managed by APM, Advanced Power Management. For your images, PNG stands for Portable Network Graphics, while AGP is your accelerated graphics port. Finally, we've got ACPI, the Advanced Configuration and Power Interface. You know, notice how these names literally just describe their exact jobs?
Let's round out your study arsenal with a final rapid-fire round of specialized terms. Ready? GIS, Geographical Information System. CAD, Computer-Aided Design. SATA is your Serial Advanced Technology Attachment. Here's a real tongue twister. APIA, Automatic Private Internet Protocol Addressing. And finally, DEC represents the Digital Equipment Corporation.
So there you have it. You now have the core formula, the chronological history, and the exact abbreviations you need to completely crush this material. We've journeyed all the way from those heat-generating vacuum tubes of 1946 to the ultra-large-scale integration and AI of today. But looking at this incredible, just blistering pace of change, it leaves us with one massive, thought-provoking question. What in the world will the sixth generation of computing look like? Thanks so much for joining me on today's Explainer. Keep up the awesome studying, and I will see you next time.